Welcome, my dear students, on a new lecture on functional analysis. So, in the previous lecture, we have discussed about Riesz's representation theorem. So, Riesz's representation theorem establishes the existence of a unique bounded linear operator associated with a sesquilinear form. So, the theorem states that let H be a sesquilinear form from defined from H1 cross H2 to K, where H1 and H2 are Hilbert spaces over the over the same field K. Then H can be represented in the form H of xy is equal to inner product Sxy, where S is a map from H1 to H2. H is bounded, H is linear, and S is unique. And also, norm H should be equal to norm S. So, this theorem states that associated with every sesquilinear form, there exists a unique bounded linear operator. And also, associated with every bounded linear operator, we can identify it with a sesquilinear form, and it satisfies h of xy is equal to inner product sxy. So, this is the general idea about Riesz's representation. So, every sesquilinear form which is defined from the Cartesian product of two Hilbert spaces onto a scalar field can be identified with respect to a bounded linear operator, and that bounded linear operator should be unique, meaning associated with every sesquilinear form there should exist a unique bounded linear operator. There should not exist more than one bounded linear operator associated with a particular sesquilinear form. This was the idea. So how will we, so we have proved this. Okay, so we have proved that h of xy is should be of the form inner product sxy, and also we have proved that S is bounded and S is linear. So in the previous video we have proved that associated with H, the sesquilinear form, it can be represented in the form inner product Sxy, where S is a bounded linear operator. Now we have to prove that this bounded linear operator should be unique, meaning associated with a particular H we have a unique boundary linear operator S. So we will prove this by a previous lemma which states that inner product xy and inner product zy are said to be equal for all y if and only if S is equal to z. That's the result. So we have to prove that S is unique. So first we assume that there exists a T which is from H1 to H2, and also for all x element of H1 and y element of H2, h of xy should be of the form inner product Txy. So we have already established that h of xy should be of the form inner product Sxy. So from this we have assumed that associated with H we have two bounded linear operator S and T, both are from H1 to H2, such that h of xy is equal to inner product Exy and h of xy is equal to inner product Sxy. Now we equate this, that is h of xy should be equal to inner product Sxy, which should be equal to inner product Txy. So this is the general idea. Now inner product Sxy and inner product Txy are said to be equal. This is true for all y element of H2. So from this we can write inner product Sxy minus inner product Txy should be equal to 0. This is inner product Sx minus Tx comma y is equal to 0. This implies inner product S minus T of x comma y should be equal to 0 since S and T are linear operator. Okay. Now we have already proved that inner product xy is equal to 0 for all y implies x is equal to 0. So this is inner product s minus t of x y equal to 0. By this lemma, this implies s minus t of x should be equal to 0, which implies xs is equal to tx, which implies s is equal to t. So we have started with assuming there exists another bounded linear operator associated with the sesquilinear form H, and it satisfies all the previous condition. So now we have proved that both of these linear operator associated with the sesquilinear form becomes same. So associated with a particular sesquilinear form, we should have a unique bounded linear operator. So S should be unique. So this concludes the Riesz's representation theorem's proof. So first we have proved that h of xy should be of the form inner product sxy. For we defined a linear operator s from h1 to h2 and proved that s is bounded and proved that s is linear. At the end we have to prove that s should be unique. For that we consider another linear operator t and proved that s and t should be same. So this concludes the Riesz's representation theorem. Thank you.